So in a previous video, we talked about compositions of two functions, and now I want to talk about special types of um, functions called inverse functions. So these are functions that undo another function, if you will. Okay. All right. So we have two functions, f and g, are inverses of each other. If and only if f of g of x is equal to x, and for all x in the domain of g, and g of f of x is equal to x for all x in the domain of f. So you have to satisfy both of these. You have to check both directions every time. Okay, it's not enough for f of g of x to be equal to x, and it's not enough for g of f of x to be equal to x. They both have to be satisfied here. Okay, and usually if we have a function if we have a function, if we have an inverse function of f, we usually write it as f, like we look, it looks like we raise it to the -1 power, but it's actually a different sort of notation. Okay, it doesn't mean we're taking this to the -1. It doesn't mean we do the reciprocal, so don't get confused there. Usually f to the -1 is inverse notation. Okay, so if we have f to the -1, it means the inverse function, not 1 over f. So be careful there with that. Okay, so let's check to see if these functions are inverses of each other. Here we have f of x is equal to x minus 2, and g of x is equal to x plus 2. So let's see if they are, in fact, inverses of each other. So we have f of g of x is going to be equal to f of x plus 2. Okay, so we'll have x plus 2 minus 2, because we're plugging in x plus 2 for x. If we combine like terms, the 2 and the -2 will cancel, and we get x. So this direction is good. Let's see if the other direction is good. Now we can do g of f of x. That's going to give us g of x minus 2, and that's going to give us x minus 2 plus 2. If we combine like terms, these will cancel, and again we get x. So this one is also good. So yes, the answer is yes. These two functions are inverses of each other because they're either compositions in both directions are equal to x. Okay, now let's look at a of x is equal to -1 over 3x, and b of x is also equal to -1 over 3x. What do we think is going to happen here? So we can start by checking a of b of x. Okay, so that's going to give us -1 over 3 times -1 over 3x. Okay, so if we simplify this, the 3 is going to cancel here. So we end up with -1 over -1 over x. So this is the same thing as -1 divided by -1 over x. So we can treat this like multiplying by the reciprocal. So we have -1 times x over -1. The -1s will cancel, and we get x. Okay. So there we go. That works. But what's really nice here, since they're both the same function, we actually don't have to check the other direction, because if we check the other direction, it's going to be the exact same operation we had here because they're the same function. So this is one of those rare instances where a function is its own inverse. So yes, these two are they are in fact inverses of each other. Okay, how about p of x is equal to x minus 1 over 2, and q of x is equal to 2x plus 1. Okay, so let's try first. We can do p of q of x. So we'll have p of 2x plus 1. So we'll have 2x plus 1 minus 1 over 2, which is equal to 2x over 2. Since these cancel here, the 2's will cancel, and we get x. That's good. Okay, so this direction is good. Now let's check the other direction. So now we have q of p of x. That's going to give us q of x minus 1 over 2. Okay, so we'll have 2 times x minus 1 over 2 plus 1. So the 2's here will cancel, and we have x minus 1 plus 1. These will cancel. That gives us x. So this is also good. So that means, yes, once again, these are inverses. Okay, so we saw our previous example before this last one. We saw two functions that were the same. Let's see if this always holds, where a function is its own inverse. So let's do c of x, or sorry, c of d of x. Okay, so we have 4. So actually, let's slow down a little bit. So this will give us c of 4x. So that's going to give us 4 times 4x. 4 times 4 is 16. So 16x. So no. This and the really nice part about this is that if you find one of them that isn't, then you can stop right there. You know they're not inverses of each other. All you have to do is find one of them that is not, and you don't have to check the other one. So that's one nice feature of inverse functions. If you're testing to see whether two functions are inverses of each other, you can stop right there. So we see that this is not equal to x. So this is no. These two functions are not inverses of each other.